We weren't looking for a new planet. We were trying to understand one we already knew existed. You know, that quote right there from researcher Gibbs, it just perfectly captures the absolute thrill of space exploration. I mean, we set out to check on something completely familiar, and suddenly, boom, we stumble upon a massive, hidden world just hiding right in plain sight. Okay, let's dive into this.
Welcome to The Explainer. Today, we're taking a real cinematic journey. We're going to zoom all the way from the edge of a distant, fog-shrouded star system, fly right through the chaotic, fiery moons of Jupiter, and then bring it all the way back down to Earth. Because, honestly, to truly understand the future of human spaceflight, we really have to look at the high-stakes, multi-billion-dollar reality that's driving NASA's newest decisions. So, buckle up.
Section 1. Secrets in the Cosmic Fog. Our first stop is deep space, specifically a very famous, very young star system called Beta Pictoris, which sits about 63 light-years away from us. Now, scientists have studied this system for decades, and they kind of thought they had it all figured out, since they already knew about 2 massive planets there. But as it turns out, there were some massive secrets still lurking in that cosmic fog.
You see, Beta Pictoris has one of the brightest debris disks astronomers have ever observed. It acts like this incredibly dense, glowing fog. And traditional imaging cameras, well, they just get totally blinded by the glare of all that cosmic dust, making it basically impossible to pick out a planet from the surrounding chaos. But NASA's James Webb Space Telescope doesn't just take simple pictures. It uses this incredible method called spectroscopy, where its instruments capture a spectrum for every single pixel, separating the light into its component wavelengths. So instead of being blinded by the glare, Webb is literally reading these chemical barcodes of light right through the fog.
And what those barcodes actually revealed was just completely unexpected. Where researchers fully expected to just see a smooth spectrum of light bouncing off dust, they instead found a pattern of peaks and dips. Actually, scratch that. It was a very specific sequence of carbon monoxide absorption lines, meaning this wasn't dust. This was a brand new giant third planet in the system, which they've now named Beta Pictoris d. And it gets even better. Follow-up observations very quickly detected water vapor and methane too. I mean, this is a real game changer for astronomy. We aren't just spotting elusive planets anymore. We are immediately reading the complex chemical makeup of their atmospheres.
Section 2. Fire, Ice, and Jupiter. So that's the absolute magic of looking outward. But let's leave deep space for a minute and zoom back into our own cosmic backyard, specifically heading straight into the thrilling, chaotic extremes of Jupiter's moons. Jupiter's moons are just this stunning study in extremes. First up, we have fire. NASA's Juno mission recently took the temperature just below the surface of Jupiter's moon Io. And this first-of-its-kind data revealed immense, intense heating within the shallow subsurface. It completely confirms Io as an absolute hellscape. It is literally the most volcanically active world in our entire solar system, just pulsing with raw, destructive energy right beneath its crust.
But then, right next door to that raging fire, we have ice. In July 2026, the European Space Agency's JUICE probe made a really daring flyby of the icy moon Europa, passing within just 32,000 kilometers of its surface, and the data they sent back was astonishing. Their imaging spectrometer detected hydrogen sulfide and complex organics. But you want to know the absolute most surprising find? A 40% variability in methane levels across the moon's exosphere. This huge variation suggests localized venting, which means Europa's cold, mysterious subsurface ocean is very likely interacting with the surface in ways we just didn't fully realize. Fire on Io, venting methane on Europa, our solar system is just alive with chemical activity.
Section 3. Artemis II. Humans return. Now, these robotic probes are doing unparalleled work, really expanding our understanding of the universe. But, humanity has this deep, innate desire to explore these worlds ourselves. And that brings us to Artemis II, and the immense stakes of humanity's physical return to deep space.
Let's walk through this dramatic timeline. Artemis II is the first crewed lunar flyby in over 50 years. Launching on NASA's massive SLS rocket on April 1, 2026, this test flight will last a tense and thrilling 9 days, 1 hour, and 32 minutes. It is going to transport 4 astronauts farther from Earth and closer to the Moon than anyone has been in half a century, right before their targeted splashdown on April 10th. This is absolutely the crucial mission that will lay the foundation for a permanent human return to the lunar surface.
But the crew isn't just going along for a historic joyride. They are conducting vital, groundbreaking science out there in the harsh environment of deep space.
During the flight, they're going to be running the Avatar investigation, using these fascinating organ-on-a-chip devices. Think of them as essentially tiny, engineered models of human tissues. By monitoring these biological chips, scientists will study exactly how increased deep space radiation and microgravity affect human health. Because look, if we're going to survive even longer journeys to Mars, we absolutely need to understand how deep space changes the human body on a cellular level.
Section 4. Streamlining the space campaign. So let's look at how all of this builds into a broader strategy. Because reaching these cosmic heights requires making some really hard, sometimes painful, pragmatic choices back here on Earth. Let's see how NASA is streamlining this ambitious campaign to make it an actual reality.
And here is the ultimate reality check for you. $18.8 billion. That is the President's fiscal year 2026 budget request for NASA. Now, while that sounds like a massive amount of funding, in the realm of deep space exploration, it's actually a profound wake-up call. It demands a much leaner, highly disciplined approach to spaceflight. Across all of government, budgets are tightening up, and NASA has to be absolutely intentional about where every single dollar goes.
So, to stay on track for the Moon and Mars, NASA had to make a pretty sobering strategic pivot. They are canceling or repurposing massive legacy programs. We're talking about the Gateway Space Station, the Mobile Launcher 2, the SLS Exploration Upper Stage, the Universal Stage Adapter, and the HALO module. According to an interim memo from the Office of Inspector General, these systems had a combined current contract value of $5.9 billion, but they were plagued by billions of dollars in cost increases and literally years of schedule delays. So, by cutting these, NASA is shedding the old architecture to get a handle on evolving mission costs.
Because the hard truth is you just cannot fund the future if you're constantly weighed down by the delays of the past. Cutting those programs frees up vital capital to reinvest in a faster, much more cost-effective approach. NASA is redirecting those funds right into a brand new commercial Mars payload services program, developing a near-term human-class Mars lander and greatly expanding commercial lunar transportation. They're heavily partnering with private industry to innovate faster and just accelerate our entire push into the solar system.
Section 5. A focused golden age. We are entering what the NASA administrator refers to as a focused golden age of innovation and exploration. It's really all about shedding the old so we can efficiently build a sustainable reality.
All those really tough budgetary decisions, they're designed to protect one overarching vision. NASA's ultimate dual goal, Moon to Mars. The enduring Artemis campaign is all about going back to the Moon, not just to plant a flag and take some pictures, but to rigorously test the infrastructure, the spacesuits, and the commercial transport systems we're going to need to take humans all the way to the red planet. Every dollar optimized, every hard choice made is a deliberate stepping stone on that path to Mars. From reading the chemical barcodes of hidden, giant planets in the cosmic fog, to measuring the intense fires of Io and surviving the harsh reality of budgets and timelines here on Earth, space exploration really is the greatest, most suspenseful narrative of our time. With a streamlined vision and just unprecedented technology at our fingertips, what hidden giants will humanity uncover next? I really hope this explainer sparked your curiosity today, and I highly encourage you to keep looking up. We'll see you in the next one.